Uh, 4 or negative 1.5 and a 4. Yeah. All right.
Gotcha. So you found the zero slopes, and then just a question. Yeah. So 1.5, right? At this point, right? Sorry, negative 1.5, and then 4,
4.
right? Just a question. So how did you know that they were zero slopes?
Cause like that's where the function like shifts its slope. So like it goes from negative infinity to 1.5 increasing, and then it goes from increasing to decreasing, or
Yeah.
it goes from
Yeah, so that's a good way to think about it. It goes from increasing slope, right, a positive slope, to a negative slope. So if you think about anything that goes from positive to negative, it has to cross 0, right, to get from positive to negative. So that's a good way to think about it. Also, for me, I just feel like I just kind of try to envision the tangent lines, and then I kind of know that at the top of hills and at the bottom of valleys, there's always going to be a horizontal tangent line. And for a zero slopes are horizontal tangent lines, right? Because when a tangent line is horizontal, that means it's not increasing or decreasing. So it has a zero slope. Awesome. So you found a zero slope here and at 4. So what did you mark on this graph for your derivative graph?
I marked the point at 4, and I marked the point on negative 1.5, just to not have to go through the x-axis.
Gotcha. So you mark them at the x-axis, right? Because this is at negative 1.5 and at 4, and we are told that it's a zero slope. So I'm going to mark it at 0, right? Because this is 0. And at negative 1.5, it's also at 0. Okay, awesome. Okay, I'm going to cold call someone else. How about Kayla? Would you be able to come off mute? And once we have the zero slopes, what do you think our next step should be? Kayla, are you there right now? Okay, how about Courtney? Could you come off of mute? Oh, sorry. Okay, your mic doesn't work. Thanks for letting me know. Okay, Courtney, are you there? Okay. I really need everyone to be on the call and in frame of the video, so I know that people are paying attention. Otherwise, we're just basically not going to make progress on learning calc. Okay. Okay, awesome. Thanks for letting me know. Okay, I'm going to call on one more person. How about Ashley? Ashley, could you come off with me, please?
Yes.
Cool. So we found the zero slopes and we marked them down on our derivative graph. But what would you say our next step should be?
I'm not really sure.
Gotcha. Okay, so did you look at the do now directions?
Yeah.
Okay, so if you're looking at it right now, so in my hint, right, I said, remember to find the zero slopes first. And what's the next thing I said?
Hold on. Let me...
Are you able to find the do now?
No.
Okay. Okay, well, find the do now as soon as you can and try to do the problem, but I'm just gonna move on. So after we find the zero slopes, right, our second step should be to look at the signs of the slopes that aren't at 0, right? So the signs of slopes, we look to the left of this point, right? And then we see that this slope is positive, right? And then we look to the right of that point and we see the slope is negative. And then at this 0 to the right, there's this tiny portion, right, which is also a positive slope. And then we're told in terms of steepness, it goes from really positive and then it goes to 0, right? So it's a tiny positive. And then, so it would look like this. It goes from very positive, it goes to 0, right? Then from this negative 1.5, it goes negative, right? So we know it goes negative. Then it returns back to 0, right? Because it returns back to this 0 slope over here. And then it goes positive again. So this would be roughly what our derivative graph looks like. And again, with derivative graphs, like it's always just a rough sketch. You're just looking roughly, are the slopes positive or negative, and then sketching it out. There's no like precisely right answer. So I would like for everyone to copy this down in this graph in their notebooks for what it should look like. I'll give like 15 seconds for that. So Naima, you said you started negative because it was below 0. So I'm assuming you're talking about over here, the function was below 0, so you started negative. So that's the point we really want to push, because we want to avoid doing that. We don't care whether it's actually negative or positive. All we care about is whether the slope is positive or negative. And even though it's negative here, right, like even though the function is negative, we can see that the slope is clearly going up, so it's positive. So since it's a positive slope here, we start off very positive over here. We just mark a positive value. Just like when the slope is 0 here, we just mark it at 0 there, if that makes sense. Okay, but now I'm going to move on from this to our quick refresher of yesterday. So yesterday we looked at the formal definition of a derivative and the alternative. Actually, I should say alternate limit definition of a derivative. I would like for everyone to copy this down one more time. So the formal definition, and then obviously focus on the actual equations, which are here. I'm going to give around 20, 25 more seconds just to copy that down. And okay, so moving on from that, I just want to reinforce the point that when we're looking at the limit definition of a derivative, all we're saying is that these two definitions, right? These two definitions, right, which are rewritten here, all they are is they're equal to the derivative. So these two definitions right? That's what it says here, is equal to the derivative, equals the derivative. And I think like a lot of people look at these and it just looks like super confusing. And it's like, what is all this? Just remember that all of this at the end of the day, if you set an equal sign to it for a function, it should be equal to the derivative. And we all know the derivative is like the slope of the tangent line, the instantaneous rate of change, right? The instantaneous rate of change, all of them mean the same thing. It's basically the slope, the derivative. There's a bunch of different words that people use for that. So just to reinforce that idea, all of these two limits are both equal to that. Now you'll hopefully, yesterday I tried to explain these limits conceptually. Remember, recall we used the limit definition to find the slope of the secant line as the interval between the points becomes infinitely close to 0. So yesterday we looked at how a secant line is like, it's kind of a bad estimate of rate of change, right? But as you move these, as you do secant lines for like closer and closer points, let's say I do a secant line for these 2 points, right? It looks like, oh, it's a better estimate for the instantaneous rate of change. And then if I do a secant line for even closer points, it's like, wow, now this is a really good estimate for the rate of change. It almost starts looking like a tangent line, right? So again, that's the idea with these limits, is that we make these secant lines so close together, like the 2 points so close together, that eventually we just get the tangent line, and then we get the derivative, because remember the slope of the tangent line is, again, the derivative. But another thing is like, luckily, even if you don't get that at all, even if you don't understand that at all, even if you don't understand that at all, we can still use these equations. I remember when I first took Calc AB, like I don't feel like I was a good student, but like I did not even bother to like really understand what was going on with like the secant lines and stuff. But at the end of the day, I just memorized these 2 equations, and then all you have to do is just plug stuff in, and then you can get the right answer. So don't panic if you don't understand these limits conceptually and they look really intimidating, you don't even understand what they mean. If it's any comfort to you, you could probably just memorize them and then plug things in and then still get the right answer on problems. So let's look at our first example. The first example says, find the slope of the tangent line to f of x. The function is f of x equals x squared minus 4 at x equals 2 using the limit definition of the derivative. Cool. I'd like for everyone to copy down this problem first. And then you don't have to write down all the words, just get the general idea down. So like slope of the tangent line for this function at x equals 2. And then just write like limit definition. Okay, I'll give like 10 more seconds just to copy down that problem. Okay, cool. So we're asked to find the derivative, right? But again, because we're just using, in this case, they're being technical. They're saying use the limit definition specifically. So use all this complicated stuff that like we probably don't like to learn to find the derivative. But I'm gonna ask you now just to find the derivative without using the limit. So like if you were to just, if I just asked you like find the derivative of this function at x equals 2, how would you go about doing it? So take like 30 seconds to find the derivative of this at x equals 2. And once you get your answer, please chat me. Awesome, thanks, Kalia. Yep, exactly right. So we're just finding, like, we're forgoing all of the like complicated stuff we're learning, and I'm just asking you to find the derivative of this at x equals 2. And once you get your answer, please chat me. Okay, I'm seeing a lot of zeros for the answer. I will caution, remember that when we're doing, if you're doing power rule, right, to solve for the derivative, remember when we do power rule on a number such as 4 or -4, it turns into 0. So we're no longer subtracting -4. So if you chatted me and answered, try to, yeah, awesome. Okay, thank you, Emily. Okay, actually, Emily, would you be able to come off mute and take us through how you did the problem?
I substituted 2 for x, so I substituted 2 into x squared, and I got 4.
2 into x squared. Did you first do power rule or no?
At first, I didn't use it. I just substituted and put the -4, but
Okay.
-4 turns into.
Gotcha. Awesome. Thank you for that. Kalia, how about you come off mute and then kind of build off of that?
Okay, so basically, when I did the power rule, I got 2x, and then I substituted 2 for x and got 4.
Gotcha. Yeah. So awesome. That's great. So remember, we're just finding the derivative, right? So f of x, let's find f prime of x, right? Because that's the derivative. And then power rule of x squared, just to, if people need a refresher on power rule, right? So we take x squared, we bring the 2 down, right? So that's the 2, bring the 2 down, and then you subtract 1 from there. So we bring the 2 down, so we're going to get 2x, and then we subtract 1 from 2, so we just get 1. So it's going to be equal to 2x. So using power rule, we're going to get f prime of x is equal to 2x, and then we're using power rule on -4. Well, we all know that the derivative of any just like number is always 0, so it's going to be -0, so it's just 2x. So our derivative is f prime of x is equal to 2x. And then if we plug in 2, so f prime of 2, we're going to get 2 times 2 is equal to 4. So our answer is 4, right, if we just find the derivative. And we're going to go over power rule more in depth later. But yeah, right now we're learning like the long way for doing a derivative. But if you still remember how to do power rule from your previous calc like pre-calc class, should be relatively quick, but we're going to learn that later on anyway. Okay, so now we're actually going to tackle the real problem. Now that we have our answer, right, we know that the answer for this is 4. But how can we get to the same answer using our limit definition? Remember, our limit definition should equal the same thing. So this equation, if we use it on this problem, should also equal 4, right? But it's like really confusing. Like, how is this going to equal 4? Well, the answer is, here, I'm just going to copy down the limit definition again. So the limit as h approaches 0 for f of a plus h minus f of a all over h, right? That's our limit definition. So how do we even use this equation? Like, we're given this equation, right? This limit definition, but how do we even use it? I'm gonna give everyone like just 10 seconds just to catch up if they need to copy anything. You don't have to write down all this, just say, like, you could write down, like, now we're like just limit definition. So we're now solving this problem using limit definition. all this. Okay. So what we actually do here is, well, we have function, right? Our function is, we're told it's the function of a plus h, and we also have f of x, right? So literally all we're gonna do is just plug stuff in. So first, one thing to know is that our a value corresponds to our point of interest. So we're trying to find the derivative at x equals 2, right? So that's going to be our a. So it's going to be f of 2 plus h minus f of 2, right? So we just substitute in 2 for a. For the h right now, we always just leave the h in these problems. We leave the h, so don't touch the h. So we're going to just, let's put in, our next step should be to plug in 2 plus h into this function, right? So I'll show what I mean. I'll show what I mean by that. The limit as h approaches 0 of f of 2 plus h, right? So I'm actually literally just going to plug in 2 plus h as if it's x here, right? So I'm going to get, if I plug in it for x, I'm going to plug it in there, right? So it's going to be 2 plus h squared minus 4, right? Does that make sense? I literally just substituted in 2 plus h for x. Okay, so I'm going to cold call just for the next step. Tavere, could you come off mute and just tell me, like, if the next component is f of 2, how do I plug this into this function, into our function, if it's f of 2?
You plug 2 into x.
Awesome. So what are you going to get if I plug 2 into x? Like, what should I write down?
0.
Yeah, okay, yeah, so you took it a step further. I'll just show my work for right now. So I plug in 2 for x, right? So I'm literally going to write 2 squared minus 4. So in this first part, I plugged in 2 plus h, right? So I got 2 plus h squared minus 4. In the second part, I plugged in 2. So I get 2 squared minus 4. So again, I'm literally just like taking this equation and just plugging in stuff. I'm not even like doing anything yet. And you took this a step further by noting that 2 squared is equal to 4, which is minus 4 is equal to 0. But I'm just going to leave this here for right now. And then this is all over h, right? And remember, we're just going to leave the h. The h in the top and the h in the bottom are both there. And if you're wondering why, we're told, the reason is because we're told that h is going to 0, right? So we're kind of told what h is equal to. But the issue is that I can't make h 0 right now, because if I make h 0, then I have a 0 in the denominator. So we're just going to leave it there. Okay, cool. So now our job is to expand this, just to like simplify stuff. So this part is kind of annoying and tedious, but you just kind of have to deal. So 2 plus h squared, right? So I'm just going to kind of show my work for that. So 2 plus h squared, same as h plus 2 squared, right? H plus 2 squared. So it's going to be h plus 2 times h plus 2. Now, what is that equal to? That's equal to h squared plus 2h plus another 2h plus 4. So it's going to be equal to h squared plus 4h plus 4. Right, so I did that, cool. So I have h squared plus 4h plus 4. If you're able to multiply that out in your head, that's even better. If you need to draw it out, it's totally fine too. But the 2 plus h squared is equal to that. Then I'm going to subtract 4 because there's still this part, right? I can't forget about that. So subtract 4, and then the rest of the stuff. I'm going to simplify this now to 0, right? Because this is just minus 2 squared minus 4, so it's going to be minus 0. And if it's minus 0, I'm just going to delete it. Okay, so we're taking this one more step. is the limit as h approaches 0. Okay, I'm gonna cold call on someone else. Let's see. Jamal, would you be able to come off of mute and just simplify this numerator for us? So we have h squared plus 4h plus 4 minus 4. How can we simplify that just one step further?
We have to factor.
Well, we kind of already did the opposite of factoring, right? Because it was factored here, so we unfactored it. I don't even remember what that's called, but we unfactored it. But notice there's two terms here that we can just kind of cancel out. It's h squared plus 4h plus 4 and then minus 4. So what are we going to do?
Cancel out 4.
Yeah, so it's just exactly. So it's just going to be h squared plus 4h in the numerator, right? Over h. Right. Now, I would like for someone to, in chat, suggest what our next idea might be. We have h squared plus 4h over h. What can we do to simplify this even more? Awesome, Brianna, you want to come off of mute and explain what you mean by that? Brianna, are you there right now? Or are you, okay, gotcha. Okay, that's totally fine. How about Emily?
I said we could simplify and cross out the h at the bottom, and we'll be left with h plus 4h.
Yep, that's exactly right. So I can show that how we get that really quick. So we can factor out an h on the top, right? So I can take out an h because h times h would be h squared times 4 would be the 4h. So I can factor out an h. And then the numerator, I also have an h, right? So I can cancel out this h. Cool. So now we're left with something that looks much more pleasant. After all that work, we're left with the limit as h approaches 0 for h plus 4. Now we can just substitute in 0 for h, right? Because previously we couldn't do that. When we plugged in 0, we have an h in the denominator, so it's going to be bad. We can't have a 0 in the denominator. But now we did all that work and we finally canceled out the h in the denominator. So we're literally going to get it's equal to 0 plus 4, right? I'm going to rewrite this 4. And with 0 plus 4, it's equal to 4. So we did all that work, right? We got 4, and that is the exact same answer we did with power rule. So I'm going to give everyone, I'll just sit on the screen for like 30 seconds for everyone to catch up. Maybe a minute or so, actually. But yeah, again, so the limit definition of a derivative, very tedious, very annoying. But it's also simple in the sense that you just plug stuff in and then you just solve and simplify. If the problem works. Sometimes there's problems that literally just like don't work, in which case you solve the derivative in a different way and then you just like write out the limit definition. But yeah. Naima, you asked a question. Would you be able to come off mute and ask for everyone? Because I'm also not 100% sure what you mean by that.
So you did, like, you plugged in the 2, like, at the beginning, and then you did h plus 2, h plus 2, and you distributed it. I was just confused on that part.
Oh, so are you talking about over here, the 2 plus plus h squared. And then I did the work over here.
Yes.
Okay, gotcha. Yeah, so that's basically, do you guys remember like FOIL from algebra? It's the FOIL method. Basically, well, yeah, so we have 2 plus h, right? I just rewrote that as h plus 2 because that just, it makes more sense in my head because I feel like we all do math problems with like the h, the variable first. So h plus 2 squared is equal to h plus 2 times h plus 2, right? Then we basically multiply each component with each other. So that h has to be multiplied with this h, and it also has to be multiplied with the 2, right? So when I multiply with that h, I'm going to get h squared. When I multiply with the 2, I'm going to get plus 2h, right? H times 2 is 2h. Cool. I did the first component. I did that, and I multiplied by both. But now I have to do the second value. So it's 2 times h, right? So that's another 2h. And then 2 times 2, which is 4, right? So then I just simplify that all out to h squared plus 4h plus 4. And then Emily said you can also use the box method, which she finds easier than FOIL. Yeah, that sounds good too. I honestly don't know what the box method is, but I'm sure it's something you guys learned in algebra. So if that works for you, definitely do that too. But it's like the same, basically FOIL is like the opposite of factoring. So like when I would, like if I asked you to factor this, I would say like, oh, it's h plus 2 times h plus 2. But I'm now doing the opposite of that. I'm just multiplying it back out. So I'm like going back to this long form. Anyway, but this is all we're doing today in class. So just remember tomorrow, make sure you're here on time. So like you should be in the Zoom call at 9 a.m. on the dot if you want full time for your quiz. Besides that, just turn in your exit ticket and your class notes today, and that should be it. Your exit ticket was probably going to be kind of difficult, but it's basically this exact type of example problem. So if you want to like walk through the exit ticket while looking at this example problem, you should be fine. I will stay after class for anyone who has questions, but yeah, you guys are free to go for now. Bye, Clarissa. Have a good day, everyone. And tomorrow's Friday, so look forward to that. Does anyone have any questions?